In this video, you're going to learn how to multiply radical expressions and rationalize. Let's get started with A. We have the cube root of 2, and then we have this parenthesis here. So that means that we're going to distribute here, right? So let's begin. We're going to multiply the cube root of 2 times 5 times the cube root of 4. Now, we can only multiply the cube root times the cube root. Therefore, the 5 is going to be on the outside, and then we're going to multiply both of these cube roots together. Since they have the same index, we can multiply them together. So, the cube root of 2 times the cube root of 4 is the cube root of what? 8. Then, now we're going to multiply the cube root of 2 times this. Of course, we go ahead and put our minus 3 times the cube root of 16. So we put the 3 in the front, and then we multiply the 2 times the 16. That'll give us 32. Now, the cube root of 8 can be simplified to 2. So we're going to put 5 times 2 here, minus 3 times. Now, 32 is not a perfect cube, but it contains 8 as its factor. So we must break up 32 into 8 times 4. So we have 10 minus 3 times 2 cube root of 4. And where did the 2 come from? From the cube root of 8. So we have 10 minus 6 times the cube root of 4. Now here's a question for you. Can we subtract 10 minus 6? So are you sure? Well, no, we cannot, because in order to add or subtract radicals, you must have the same index and same radicand. Therefore, we need this to be 10 cube root of 4 in order to subtract 6 cube root of 4. And we don't. It's simply 10. And it doesn't have a radical that's the same as cube root of 4. So that's our final answer. Let's move on to B. The square root of 3 times the square root of 6 is the square root of 18. Also, square root of 3 times the square root of 15 is the square root of 45. Now, can we do anything with the square root of 18 and the square root of 45? Yes, because the square root of 18 contains 9 as a perfect square. 45 also contains 9. So we're going to break it up like so. Now the square root of 9 is 3. It goes on the outside. Similarly with the square root of 9 times 5. Now the question is, can we add these two together? These two radicals together? No, again, we cannot add unless we have the same radicand, and we do not. No, they are different. Therefore, this is your final answer. Moving on to the next, let's move to C. Now the square root of 6x times the square root of 8x is the square root of 48x squared plus square root of 6x times square root of 12xy is 72x squared y. And then we have the square root of 48 can be broken down into 16 times 3. And x squared is also perfect squared, so we'll come back for that. 72 has a perfect square factor of 36. And again, x squared is a perfect square. So what we're going to do is put some space in the front of our radical so that we can take everything out. So notice that the square root of 16 and x squared, square root of x squared can be simplified. So definitely 4x will go out. Now that 3 will remain under. Again, we have the square root of 36 and x squared. So what goes out is the 6, right? And the x. But the 2y stays under. Now the question is, can we add these two together, these radicals? No, we cannot, because notice that we have a 3 and a 2y. They're not the same. So we cannot add these two terms together. Let's move on to D. Notice here that we have a binomial times a binomial. And when we have a binomial times a binomial, we FOIL. So the square root of 2 times the square root of 5 is square root of 10. Then the square root of 2 times negative square root of 7, negative square root of 14. Then inner, we have plus square root of 15. And then square root of 3 times negative square root of 7 is negative square root of 21. If we look closely at each of these numbers under the radicals, they do not contain perfect square factors. Therefore, we are done with this problem. We're going to move on. In order to multiply radicals with other radicals, what needs to be the same? If you said index, then you are correct. In order to add or subtract radicals with other radicals, what needs to be the same? If you said index and radicand, then you are correct. You try these problems here and then play to reveal the answer. So hopefully you have completed these already. I'm going to proceed. So if you multiply square root of 2x times simply x, then hopefully you look back at these rules. You can't multiply 2x times this x because this x doesn't have a radical. So that x is going to go on the outside. Okay? Because it's not the square root of x. It's just simply x. Plus, and then we'll multiply square root of 2x times the square root of 2x. Now, both of them have the same index. So you can multiply what's under the radicals, which is 4x squared. Since 2x times 2x is 4x squared. Now, x times the square root of 2x, nothing to do there. But here, these are perfect squares. So you would reduce that to that. So hopefully you said x radical 2x plus 2x. Moving on, square root of 3ab times 3a. We can multiply these together because they have the same index. So we have the square root of 9a squared b plus square root of 3ab times 9b. Square root of 9b is square root of 27 ab squared. Now, notice that we have 9, we have a squared. So definitely for the first radical, we take that 3 out and an a out because the square root of a squared is a, square root of 9 is 3. But the b stays under. Now this 27 can be broken down into 9 times 3. So we have 3a squared of b plus, we're going to take that 3 out here. And also a b can be taken out, but a 3a remains under. So that's the final answer for this particular problem. Moving on, we have a binomial times a binomial. So let's multiply this times this. So that's 6 times the square root of 25. This times this would be 3 times the square root of 15. inner would be minus 4 times the square root of 15. And then last, we have negative 2 times the square root of 9. Now we're going to simplify. 6 times 5, since the square root of 25 is 5. But notice we have like terms here. They have the same index and radicand, so we can bring them together. 3 minus 4 is negative, so square root of 15 here. Minus 2 times 3, since the square root of 9 is 3. So we have 30 minus square root of 15 minus 6. We have like terms here. 30 minus 6 is 24. So we have 24 minus square root of 15. Next, we have square root of 6 plus 4 times the square root of 6 minus 4. Notice that looks like sort of like difference of squares, right? So the square root of 6 times 6 is the square root of 36. Square root of 6 times negative 4. Again, notice that the 4 doesn't have a radical on it, so it goes to the left of the radical. Then inner, we have 4 radical 6. And then 4 times negative 4 is negative 16. Alright, so the middles cancel out. And square root of 36 is 6 minus 16, which equals negative 10. Again, we have, and it's coming up, what we call conjugates, where you have square root of a minus square root of b, have square root of a plus square root of b. Notice the only thing that's different again are the signs in the middle. So you should expect something similar to what happened in the last problem. So the square root of a times the square root of a, square root of a squared, square root of a times square root of b is square root of ab. And again, since they're both square roots, we can multiply what's under the radicals together. And then that's minus square root of ab. And last, we have minus square root of b squared. So again, notice the middles cancel out. And we have the square root of a squared, which is a, minus square root of b squared is b. So the final answer is a minus b. So what's different about the last two problems? Notice that the middles cancel. The middles cancel. And that always happens when you have an expression like a plus b times a minus b. So these are called conjugates of each other. So the conjugate of a plus b is a minus b, and the conjugate of a minus b is a plus b. Alright, so the only thing you change to find a conjugate is the sign in the middle. So recall from the difference of squares formula, we have something like a plus b times a minus b. Notice again, only what's in the middle is different. When that happens, the middles will cancel. So really, you only have to multiply the a times the a together, which is a squared minus, and the b times that, so b squared. So notice the middles will cancel out because it'll be ab minus ab in the middle if you FOIL this out. But if they're conjugates, you can really skip those two steps in the middle. Again, for example, you tried 2 radical x plus 7 times 2 radical x minus 7. Are they conjugates? Yes, they are. So you try it and then pause the video and then play once you arrive at your answer. Alright, so I'm going to FOIL the whole thing out, and hopefully you'll see that really you only had to do is multiply the first two and the last two, but I'm going to FOIL it all out so you can see. So 2 radical x times 2 radical x is 4 times the square root of x squared, since 2 times 2 is 4, and x times x is x squared. Alright, so I did that first, and then you could have done this if you fold it all out. Minus 14 radical x, then inner plus 14 radical x, and then last minus 49. Again, since these are conjugates, the middles will cancel out. Then you have 4x minus 49. 4x minus 49 as the final answer. A radical expression is not in simplest form if a radical is in the denominator. When this happens, we must remove the radical by a method we call rationalizing the denominator. So, for example, we have a radical here, square root of 2/3. This is first considered to be the square root of 2 divided by the square root of 3. However, this rule says that it's not in simplest form if a radical is in the denominator, and we do have a radical in the denominator. So what we do is we rationalize it. We try to get that radical out the denominator. So what you can do is multiply the denominator by a radical that would make that radical disappear. And in this case, you can multiply it by the square root of 3, because the square root of 3 times the square root of 3 is the square root of 9, and 9 is a perfect square. So you want to multiply it times a number that will give you a perfect square in this case. Now, if I multiply the denominator by the square root of 3, obviously I have to multiply the numerator by the same thing, or else we have altered our problem forever. So now, let's look at the denominator. Again, that's the square root of 9. Numerator is the square root of 6. So we have the square root of 6 over 3. So notice here that our radical is out of the denominator, and that's what rationalizing is. Getting that radical out of that denominator. Moving on, B. B looks very similar because we have a 2 over square root of 3. So again, to rationalize, we'll multiply top and bottom by the square root of 3. However, notice in the numerator now we have 2 times the square root of 3, not 2 times 3. Okay? 2 times the square root of 3. And then we have the square root of 3 times the square root of 3, which we know now is square root of 9. So 2 times the square root of 3 over 3. Again, radical is out of the denominator, and that's what we wanted. C is a little bit more complicated. What you could do is simplify it first, or you could multiply it by the square root of 32x. But let's see if we simplified it first, what would happen. So I'm going to say equals. And what I mean about simplify is 32 contains a perfect square. So we could get that perfect square out first. 16 times 2 times x. And then square root of 16 is 4. So we can take that 4 out. And notice that, can you notice that 4 can actually go in 8? So what we have is 2 over the square root of 2x. Now, you think you're done, but the problem is, again, and we underline again, a radical expression is not in simplest form if a radical is in the denominator. And as you can see, we still have the square root of 2x in the denominator. So we need to multiply it by something that will give us a perfect square. And in this case, it would be the same thing, square root of 2x. So notice in the denominator now we have square root of 4x squared, and in the numerator we have 2 times the square root of 2x. So I'm going to come over here. So we have 2 times the square root of 2x over 2x, because the square root of 4x squared is just simply 2x. And notice we could cancel out the 2's here. Equals square root of 2x over x. Now you should try possibly just multiplying this by the square root of 32x top and bottom to see if you can get to that same. And next we have a situation. Notice that we have a binomial in the denominator. So it's not as simple as the first 3 examples. So we do need to rationalize this denominator. And we're going to do that using that information about conjugates. Notice when we use conjugates before, things cancel out. So we're going to use that to our advantage here. we're going to multiply the denominator by the conjugate, alright? Radical 5 plus radical 2. What is this conjugate? So let's multiply by radical 5 minus radical 2. And of course, we have to do the same to the numerator. So the numerator, simply just write the numerator down. Don't try to simplify at first, okay? So we have 4 radical 5 minus radical 2 here. Put that in parentheses. But since these are conjugates of each other, we don't have to multiply everything out. So I'm going to simply multiply square root of 5 times the square root of 5 is 5. Because the square root of 5 times the square root of 5 is square root of 25, which is 5. And the square root of 2 times the square root of 2 is 2. So, see how simple that was? I didn't FOIL that out because I knew that the middle terms would cancel. So we have 5 minus 2, which is 3. We have accomplished our goal because we do not have a radical in the denominator. And that was our intent. We don't care about the radicals in the numerator. And we can leave our answer like this. It's perfectly fine to leave it as 4 times the square root of 5 minus square root of 2 because there's nothing to simplify in this case. If you wanted to multiply that through in this case, it's okay. But in this particular case, it's not necessary. Now let's move to E. What is the conjugate of radical 7 minus 1? It's radical 7 plus 1. So we're going to multiply top and bottom by radical 7 plus 1 again. You can simply write 2 times the square root of 7 plus 1 in the numerator. But in the denominator, square root of 7 times the square root of 7 is square root of 49, which is 7. Negative 1 times positive 1 is minus 1. So you have 2 times the square root of 7 plus 1, that's in parentheses, over 6. But notice here, 2 can go into 6. That's why it's an advantage if you just leave those numbers in the front, not to multiply them through yet. So don't do that until you see that you have simplified all the way. And here we have a situation where 2 can go into 6 3 times. So that's square root of 7 plus 1 over all over 3. For F, we have the square root of 2 minus 7. So the conjugate is the square root of 2 plus 7. So we're going to multiply top and bottom by the square root of 2 plus 7. So in the numerator, we're going to keep it as 7 times the square root of 2 plus 7. No need to multiply that out just yet. In the denominator, square root of 2 times the square root of 2 is 2. And negative 7 times positive 7 is negative 49. So we have 7 times the square root of 2 plus 7 over negative 47. And we're going to, it's conventional that we move that negative up. So we're going to put negative 7 parentheses square root of 2 plus 7 over 47. So we'll move that negative up to the side or to the numerator. Alright, lastly, we have a challenge. And normally I would give this out in class, but we're going to work on it. So we have, let me rewrite it, cube root of 5 over 9. Again, split that up as the cube root of 5 divided by the cube root of 9. And as you can see, we're not done because we have a radical in the denominator. So we're going to have to rationalize this. Now, this is the cube root, so we have to do this a little differently. We want to multiply 9 times a number that will give us a perfect square. We need to multiply 9 times a number that will give us a perfect cube. So what would that number be? So we'll multiply it times the cube root of 3, top and bottom, because 9 times 3 is 27, which is a perfect cube. So here we have the cube root of 27 in the denominator, and we have the cube root of 15 in the numerator. Now the cube root of 27 is 3. So we have the cube root of 15 divided by 3. This is the final answer. And this concludes our lesson on multiplying radical expressions and rationalizing.